So I'm a fourth-year PhD student at University of Zurich. Have you guys ever felt an earthquake? Okay, so I cannot move. Is there a mic or something?
You want to? Yes, sure.
So. So, have you guys ever felt an earthquake? Or ever been caught in a hurricane, a flood, maybe a forest fire? Okay. Have you ever shared your disaster-related experience on social media to inform your family and friends that you are safe, or maybe you are in need of help? Well, a lot of users share disaster reports on various social media platforms every single day. Twitter is one of the most commonly used platforms with millions of daily active users worldwide. For my research, I collect tweets posted on Twitter during natural disasters to get the information. However, it's not that straightforward to collect only what I call information from a bunch of other tweets which are not information for me, or maybe which are noise. So what do I do? What do I mean by information? This is a very classical example of an eyewitness report where user is telling about an airplane crash in Hudson Bay. And this is an eyewitness report where user experienced the event themselves and then they shared the report. So why am I interested in eyewitness reports? Because eyewitnesses are considered credible sources on social media. And especially if we talk about practitioners in emergency response offices, they are mostly interested in the sources which are more credible. So this is an example of not information tweet. This is clearly stating that this report has been got from somewhere else, and they're sharing it on Twitter. So these are called non-eyewitness reports. What is noise for me is something like that, which doesn't make any sense in response to a natural disaster, though they are using keywords which are related to natural disasters, such as earthquake, an earthquake in American politics. Though this is a more frequent phenomenon nowadays because elections are approaching. Well, so what did I do? I collected tweets from Twitter Streaming API. So I knew that I want them in eyewitness, non-eyewitness, and noise. But first, I performed manual analysis to know if there are more types of eyewitness reports within the eyewitness tweets. And I found out that there are three other types, which is very interesting: direct eyewitness, indirect eyewitness, and vulnerable direct eyewitnesses. These are from the perspective of natural disaster. So what do I mean by direct eyewitnesses? This is something that someone has felt the earthquake or any natural disaster by themselves or its impacts, and they're reporting on Twitter. So it features something like big midnight earthquake and aftershocks now. So the words in red blocks, they are telling about the features based on what I am categorizing them as direct eyewitnesses. So an example of indirect eyewitness. By indirect eyewitness, I mean someone who is not present in the disaster region, but they are reporting from their family or friends who are present in disaster hit region, and they are experiencing that earthquake or whatever natural disaster is going on. So for example, my wife and kids are in Tokyo, and they are in the middle of an earthquake. So this is also kind of a credible report because that person knows those people who are present in disaster hit region. What do I mean by vulnerable direct eyewitnesses? So this was a very interesting example when we were performing this manual analysis, that people were present in a region for which warnings were already issued. So this was not the case for earthquake, for sure, but for floods or hurricanes or forest fires. So in this example, there is some routine activity. Why I always napping? I am always napping when a flash flood warning comes on my phone. So, and scared. So they are experiencing, they are telling about their emotions, and there are other characteristics. So, of course, when we did this manual analysis, we had to come up with some characteristics or features based on what we are saying that these are direct eyewitnesses, indirect eyewitnesses, or vulnerable eyewitnesses. We call them domain expert features here. So these are a bunch of characteristics. Some are a bit abstract, some are very straightforward. So for example, reporting small details of vicinity, words indicating perceptual senses, these are, of course, very straightforward. Impact of disaster, personalized location markers, my office, our area, in my city. So they are not using straightforward the toponyms of those locations. Time in the indicating words, now, at the moment, I just felt, for example. So for indirect eyewitnesses, we also have a bunch of characteristics where they're referring to someone in their family or their friends. They're using first-person adjectives, expressing emotions. They are worried, relieved. They are complaining sometimes, reporting safety or damage or missing reports, for example. For vulnerable, we found some overlapping with direct eyewitnesses. So characteristics from 5 to 9 are overlapping in vulnerable and direct eyewitnesses. And these are the distinct characteristics of vulnerable eyewitnesses, which are somehow overlapping with indirect eyewitnesses. So here comes two challenges after this manual analysis. Now we wanted to operationalize those features and train a machine learning algorithm. And because there is a bulk of tweets coming from streaming API, it's not possible for someone to do it manually and extract those tweets which are interesting or which are information for them, and then use them for their analysis. So the two challenges is, first of all, how to feature those characteristics, some of those characteristics, which are very abstract. For example, here, details about vicinity. So there can be a whole bunch of different options which we cannot predict and which we cannot make our machine learning algorithm to predict. So we kind of omit some of those characteristics which were very abstract to operationalize. And the second challenge was to identify between those eyewitnesses, types of eyewitnesses, which are direct witnesses, indirect witnesses, and vulnerable witnesses, because of lack of data to train the model. Though we performed this analysis 2 times, we first had manual analysis by ourselves, then we collected again some data, and we performed crowdsourcing on a crowdsourcing platform to collect more data, but still we didn't have enough tweets to train our machine learning algorithm, which was random forest, to predict those tweets. So what we did, we merged those classes, and then we had, for our machine learning algorithm, we again had this eyewitness tweets, non-eyewitness tweets, and noise. We trained 4 machine learning algorithms. Textual features, bag of words model, simple, that was our baseline, most frequently occurring terms. Then secondly, we had domain expert features, which we identified as features, and we train our algorithm on those features only. Thirdly, we combine text features, bag of word model, and then our domain expert features. And then we again performed our analysis. And fourthly, because our classes were really imbalanced, so we tried class balancing techniques mode to see if our results are better. So these are the results, because we did it on 4 disasters, but this is only, I will share only 2 disasters results because of the time. So because our classes are really unbalanced, here you can see This is class distribution. So eyewitness types are 1600, then non-eyewitness are 200 here, and then noise is again 200 tweets, which is a huge imbalance within, total was 2000 tweets, which is a huge imbalance within those classes. So here we added some more data with SMOT technique, and then though we cannot, if we interpret these results, we can not straightforward say that, okay, the first model performed worse than the second or the third one, or the fourth model was the best. However, here, if you see, there are, for non-eyewitness, for noise, its F-score is a little bit better than with domain expert features. And if we combine both of them, it's still less than the basic technique, this bag of words model. But if we do class balancing, it starts getting better. So it depends on the classes and on the class distribution as well. So these are the results of wildfire. So here it seems that they are kind of working better as we combine the textual model and the domain expert model here, or when we do this class balancing again here, it's giving us better results. So the full paper is here. You guys can have a look for the full discussion or the results or how we perform the analysis. So I'd like to conclude by saying finding first-hand and credible information during disasters is an important task for relief organizations. And these automatic methods to extract these credible information from social media can lay the foundations of future communication. Thank you.